This is the third video for functions. It's based on notation, and it's a continuation of the first video, which was talking about the domain, codomain and range, and the second video, which was the mapping diagrams. So the fancy way to write the above rule, and if you can remember from the first video, we had the rule where we had an input, and what you did to that input was you added 3 and then you multiplied by 5. And then what you do is you get your output. So this is quite long-winded in terms of if you had to write this out every single time, it gets a little bit confusing. So what mathematicians have done is they've come up with a way or a language of writing functions. Now I know you'll be dreadfully excited to figure out what this language is, because it's so interesting. But this really does make our life much easier, and although it might be a bit confusing to start with, it definitely is so much better than writing out English the entire time. So what they have, instead of writing this, they have f of x is equal to 5x plus 3. So our input is x, we add 3 to that, and then we multiply the whole thing by 5, and that will give us our output. So there's 3 different ways to write f of x. So we can write it as f of x with the brackets, we can write it with f dash dash x and then a little arrow, or the way I like the best is y. Because obviously we're used to coordinate geometry and plotting points and figuring out where they are on a graph, and we usually talk about x and y. So if you put in, for example, 3, that would be your x value, your y value might be 2, for example. I find that's about right. Now, if there's more than one function in a question, the examiner usually calls the second one g of x, although he can use any letter at all. And usually what happens is you can see h of x after g of x, but f of x, g of x and h of x are the 3 main ones that you would see. So the best way to kind of get used to or get to grips with how this works is by just doing a few examples. So if f of x is equal to 3x minus 7, this is question 1.2. So f of x is equal to 3x minus 7. So what this means is if you take the function, so f usually stands for the function, and you put in 2, what are you going to get out? Well, what we have here is we replace the x, so we've replaced the x here with 2, so we replace all the other x's with 2. So it becomes 3 by 2 minus 7, which is going to give you an answer of minus 1. So that's the first one done. That's all you have to do. The second one then, again, write out f of x is equal to 3x minus 7. They want f of 0. So what we've done now is we've replaced the x with 0. So this becomes 3 times 0 minus 7. So the answer for this one is going to be minus 7. So then the last one we have here is f of minus 8. So the third one. So again, always write out the function. So f of x is equal to 3x minus 7. And we're looking for f of minus 8. So it becomes 3 times minus 8 minus 7. And when you type that into your calculator, you're going to get minus 31. So I'm hoping that makes some sense. Bearing in mind the key thing to take from this is that all of these equal the same thing. So f of x, f dot dot x, arrow, and y all mean the same thing. So it's what happens when you put a certain number into a function. Now another type of question you could have is like the one here in question 1.3. So it tells you that f of x is equal to 6x minus 4, and that f of x itself is equal to 38. So if fx are equal to the same thing, well then 6x minus 4 is also equal to 38, because f of x is equal to 6x minus 4 and f of x is equal to 38. So if both of f of x are equal, well then they have to be equal here too. So then we just solve this to find what x, so we plus 4 to both sides, so we'll get 6x is equal to 42, and then we divide both sides by 6 and we'll get that x is equal to 7. And I'm hoping that is making a bit of sense. The hardest part about this is when we have here, so we have f of x here and here, just making sure that, well, if f of x is equal to one thing and f of x is equal to another thing, then those two things also have to be equal because they're both equal to f of x. I'm hoping that makes a bit of sense. Now the next example here, so with question 1.4, so f and g are two functions such that f dot x is x squared plus 2 and g of x is 17 minus 2x. Find the values of x for which f of x is equal to g of x. So what we have, so we have f dash dash x is equal to x squared plus 2 and g dash dash x is equal to 17 minus 2x. Now they want to figure out where f of x is equal to g of x. So again, they're trying to confuse you a little bit in terms of the notation. These are both equal to the same thing, so we know that f of x is equal to x squared plus 2 and g of x is equal to 17 minus 2x. So we want to figure out where these are equal, so then we just let them equal each other. So x squared plus 2 is equal to 17 minus 2x. And then what we have to do is we just have to solve that equation. So what I'm going to do is I'm going to bring everything over to the left hand side. So here what I'm going to do is minus 17 and plus 2x. So I'll do that on this side as well. Minus 17 plus 2x. So this will, x squared will stay as x squared plus 2x. And then 2 minus 17 is going to be minus 15 is equal to 0. Now, then what you do is you do your box method, which I would hope you're all okay with or can do. You can also do your minus b formula, and you'll end up with x minus 3 and x plus 5 if you do your box method. And then we'll get x is equal to 3, x is equal to minus 5, both when you do the box method and when you do the minus b formula. So the two values for which f of x is equal to g of x is x equal to 3, x is equal to minus 5. Now, another way you could have done this is you could have graphed them. However, we haven't got to that stage in functions yet. So at the moment, we're just kind of dealing with the algebra of functions. So you could have graphed it, and if you wanted to graph it for this one, you could have. But because we haven't got there, I was doing the algebraic version of it. So question 1.5 looks a little bit more complicated than it actually is. And a lot of people start to freak out a little bit when they see it. But what we have is we have f dot x goes to 1 plus 2 over x. And they want to figure out where, well, f of a third is equal to k times f of 2. Now, so I'm going to change this into the way they have it. So f of x is equal to 1 plus 2 over x. So if we figure out, first of all, what f of a third is, that's going to be 1 plus 2 over a third. You can pop that into your calculator and you'll get the answer of 7. And then, right, so we have k f of 2. Right, so we can't really do much with the k because we just know what it is. But then f of 2 would be 1 plus 2 over 2. So then this would be equal to k of 2. Now, when we have k and we multiply it by 2, we rewrite that as 2k. So we have f of a third, and we figured out that that's 7. And then this is going to be equal to 2k. Now, if you look at the question, it's asking us to find what the value of k is. We know that 7 is equal to 2k. So if we divide both sides by 2, we can figure out that k is equal to 3.5. So I've kind of split it up. So I split this section here, and I figured out what that was. I then figured out what this one was down here, and then I kind of put it together to figure out what it was in the end. So I'm hoping that that is making a bit of sense. Question 1.6, so it tells us that g of x is equal to the square root of 5x minus 2, and it wants us to find g of 2. So what we have is we have, well, the g of x is equal to the square root of 5x minus 2, and it wants the g of 2. So every time we see an x, we replace it with 2. So we have 5 of 2 minus 2. Now, you can literally type that into your calculator. What you will get is you'll get the square root of 8 if you work it out. So 5 times 2 is 10. Take 2 will give us 8. Now, it says give your answer in the form a root a, where a is an element of n. Now, n, again, I hope you can remember, are our natural numbers. That's going back to the number chapter. So we have our natural numbers, integers, rational numbers, and real numbers. I won't go into too much detail about them at the moment, but I'm hoping that you know what they are. So at the moment, square root a doesn't look like a root a. A lot of people start to panic now, they start having emotional breakdowns. What you need to do is just type root 8 into your calculator. You'll end up with 2 root 2. And that's all you have to do. That's this question completely finished. Now, the final type of question that you can be asked is something like the one here. So, if f of x is equal to x squared plus 3x minus 7, show that f of x plus 1 plus 3 is equal to x squared plus f of x. So, we know that first of all, f of x is equal to x squared plus 3x minus 1. Now, here they're talking about f of x plus 1. So, we figure out what that is first. So, every time we see an x, we replace it with x plus 1. So x plus 1 squared plus 3 times x plus 1 minus 7. So this is going to become x plus 1 times x plus 1. I hope we're all okay with that. Plus 3x plus 1 minus 7. So x plus 1. Now I'm going to figure out what this is. So x by x is x squared plus 1x plus 1x plus 1 plus 3x plus 3 minus 7. And then you can tidy all that up and you'll be left with x squared plus 5x minus 3. Yeah, so that's what f of x plus 1 is. So now they want f of x plus 1 plus 3 is equal to x squared plus 5x. So write that out. So we know that f of x plus 1, we figured that out and we said it was x squared plus 5x minus 3 plus 3 is equal to x squared plus 5x. So we have 3 take 3, that'll give us nothing, and we'll be left with x squared plus 5x is equal to x squared plus 5x. So we're done. The both of them are equal, and that's completely perfect. And that brings us to an end of this video. If you do have any questions again, just send us an email and I will get back to you straight away.